some quadratic equations using the quadratic formula. Let's look at our first problem. We have x squared plus 5x plus 6 is equal to 0. Okay, I want to use the quadratic formula to solve this, so I first identify a, b, and c. A is 1, that's the coefficient of the squared term. B is equal to 5, and c is equal to 6. So a is 1, b is 5, c is 6. Now, we have to have memorized the quadratic formula. I'll write it down here. X is equal to negative b plus or minus square root b squared minus 4ac, all divided by 2a. And so once I have this formula memorized, all I have to do now is substitute in a, b, and c into the formula, and I'll have my two solutions to this equation. So x is equal to negative b, so negative 5, plus or minus the square root of b squared, so that's 25, minus 4 times a, which is 1, times c, which is 6, all divided by 2 times a. Now I'll continue to simplify here. I'll end up with negative 5 plus or minus square root of 25 subtract 4 times 1 times 6. 4 times 1 times 6 is 24. 25 subtract 24 is 1. And then 2 times 1 is just 2. Continuing to simplify, square root of 1 is 1, so I have negative 5 plus or minus 1, all divided by 2. And so this will give me my two solutions. My first solution is going to be negative 5 plus 1 over 2, which is negative 5 plus 1, or negative 4 over 2, which comes out to be negative 2. And my other solution is negative 5 minus 1 over 2, which will be negative 6 over 2, or negative 3. So I have my two solutions, negative 2 and negative 3. One solution I get when I take the plus sign here, and the other one I take the minus sign. So it's negative 5 plus 1, negative 5 minus 1, and I end up with negative 2 and negative 3. Now, I'm sure you're aware of this, but this equation also can be solved by factoring, and you should solve it by factoring yourself just to convince yourself that the work we're doing with the quadratic formula gives us solutions that are consistent with the solutions we got when we just used factoring. Now, let's take a look at a problem that we solved using the quadratic formula that can't be factored. I have x squared minus 5x is equal to 7. The first thing I want to do is put this in standard form. I'll do that by adding negative 7 to each side. I end up with this expression. So I have to identify now a, b, and c. A is equal to 1. That's the coefficient of x squared. B is equal to negative 5. And c is equal to negative 7. Next, I put these numbers into the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c. All that's divided by 2 times a. I'll continue to simplify here. The opposite of negative 5 is 5, plus or minus the square root of, let's see, 25 minus 4 times 1 times negative 7. That'll be a positive 28. So 25 plus 28, that's going to come out to be, let's see, 53. That's all over 2. And so I end up with negative 5 plus or minus square root 53. Now, can this be simplified? No, there's no perfect squares that are divisors of 53 that we can take out from under this radical. So I have my two solutions. One is x equal 5 plus square root 53 all over 2. And the other solution is 5 minus square root 53 all over 2. So even though I can't simplify this and get a nice number for the solution, I still have two solutions. One is 5 plus square root 53 over 2, and the other is 5 minus square root 53 over 2. With the calculator, I can get a nice decimal approximation to these things and give me a better idea of what the solutions look like. Let's do one more problem. I have 3x squared equals negative 4x plus 2. Let's write it in standard form. as 3x squared plus 4x minus 2 equals 0. We add 4x to both sides, and we add negative 2 to both sides. We have our equation in standard form. It must be in standard form for us to identify A, B, and C. A is 3, B is 4, C is negative 2. Okay, into my quadratic formula then, x will be negative b plus or minus square root of b squared minus 4 times a, which is 3, times c, which is 2, all divided by 2a. I continue to simplify now, and I get negative 4 plus or minus square root of, okay, 16 subtract, let's see, 4 times 3 times, oops, made a mistake, negative 2. Let me put the negative sign there. C is equal to negative 2, so minus 4ac. Got the negative 2 there. 4 times 3 is 12, times 2 is 24. That'll be a positive 24 plus 16 should give me 40. Okay, all divided by 2 times 3 is 6. Okay, we'll move that up a little bit to give ourselves a little more room. And then let's see, 40 is 4 times 10. 4 is a perfect square, which I can take out as 2. So this would be negative 4 plus or minus. I simplify this radical, and I get 2 square root 10, all divided by 6. And now when I look at this, I see that 2 divides the numerator and 2 divides the denominator. I can show that by factoring a 2 from the numerator. I'll have 2 times negative 2 plus or minus square root 10. And I'll factor a 2 from the denominator and have 2 times 3. Now notice if I multiply 2 times negative 2, I get negative 4. 2 times square root 10 is 2 square root 10, so that makes sense. See, I have a 2 as a factor common to the numerator and denominator. I'll divide it out. And what I end up with is, let's write it over here, negative 2 plus or minus square root 10, all divided by 3. So there's my solution, and it's not that this solution right here is incorrect. It's not. It's just not in lowest terms. These are the two solutions to this equation, negative 4 plus 2 square root 10 over 6 and negative 4 minus 2 square root 10 over 6. But it can be reduced to a simpler form as negative 2 plus or minus square root 10 over 3 by factoring out the 2 that's common to the numerator and denominator. Okay, so some quadratic equations you'll find will be solvable by factoring, and then there's others that aren't solvable by factoring. In those cases, we have to have something like the quadratic formula to be able to solve those equations.